we're learning about patterns and sequences, the first thing to notice is visual patterns with things like shapes. So if I've got a pattern that goes perhaps circle, triangle, triangle, circle, triangle, triangle, what I'm looking to do is see if I can spot a repeat. And in this, I can see one repeat. This is the same as this. And so I can predict that that fragment of the chain is going to be repeated again. Circle, triangle, triangle, circle, triangle, triangle. That's step one. Once I've recognised a pattern, then I can apply this to numbers. For example, 4, 7, 10, 13. Here's some numbers. Now there's no visual pattern, I can't see anything there, but I can notice a fragment of pattern, meaning a difference in each one. And the way to note this is to say, right, what's going on here? Well, it's going up, and it's going up in threes. Is this the same? Ah, yes. Is this the same? Ah. So then I can use that to predict from here on what the next parts of my pattern will be. And I've got a sequence. This idea of having the gap between each number can be applied to any different size numbers. So it could then be that we look at something much larger, or indeed we go into negative numbers. So we could have something like 2, -2, -6, and we notice what's going on. It's going down this time in fours, and that pattern will be repeated. Or even something much larger, 2,100, 2,150. 2,200, and we notice it's going up this time in 50s, and that pattern will be repeated. It can be applied to any size numbers. The next step is to create a rule for these patterns. So you might have an example of a pictorial pattern. Here's one. This is the first image in this pictorial pattern, and this has got 4 lines in it. The next one is the same with an extra box, so that's actually got 7, and that pattern will continue. And this one, as you can see, has got 4, 5, 6, 7, 8, 9, 10. So this is actually, you'll notice, the same pattern as here, but this is presented in a visual way. So each time I'm adding 3, in this case they might be matchsticks or lines, something like that. And within this step, I can describe the pattern. In each of these images, we start with a box that has 4 matchsticks. And then there are 3 added each time. So you could talk about the pattern being 4 plus 3 each time, but there's an easier way. This is the first, what's called term in the sequence. This is the second term, and this is the third term. You'll note the fourth term, without even drawing it, I know would have 13 matchsticks to draw it. We need to find a relationship between this number 1 and 4, this number 2 and 7, this number 3 and 10, and it needs to be the same relationship relating those two numbers together. So let's just have a think about that. What could I do to 2 to get close to 7? I could times it by 2, that would give me 4. I could times it by 3, that would give me 6 plus 1. Maybe it's 6 plus 1. Let's try that. Sorry, maybe it's times 3 plus 1. Let's try that. Over here, 3 times 3 plus 1. Yes, that would work. 4 times 3 is 12 plus 1. Yes, that would work. So what I'm saying is, for this pattern, you take what's called the n, the number in the term pattern, and we say whatever we do to that n, in this case, I'm going to times it by 3 first, and then add 1. That does work for this, doesn't it? 1 times 3 is 3, add 1. Yeah, it does. Now, we've used letters to represent numbers in class, and in this case, it means the number, the term number. There's a different way of writing this. We actually write 3n plus 1. Now, what this means is that I could use this to know what any of these terms would be, which it can be really useful in life when you want to work out how many of something you need or make a prediction. So for example, if I wanted to know what the 10th term in this sequence would be, well, I know 3n plus 1. I'll write that again just to remind myself. So that 3 is times, in this case, 10, because it's the 10th term. And then I'm going to add 1, so that's 30 add 1. So I know in the 10th one of this, there would be 31 matchsticks. I can predict that already. I could predict the 100th if I wanted to. Step 4 is slightly different. It doesn't really lead on from the others. Step 4 is about noticing different patterns. For example, here's one. Now you might recognise those numbers. There's two ways of looking at this. You might go back to step 2 and start thinking, okay, what's the gap? That would be a sensible thing to do. So I'll start with that. That's going up in 5. Oh, but that's not. That's going up in 7. Oh, but that's not. That's going up in 9. I can actually see a pattern in the pattern, can you? These are going up 2 each, so the pattern is increasing by 2 each time. So that would be a sensible way of spotting a pattern, but there's another. You might recognise these numbers. These are actually square numbers, so that might be something to look for. You might be given patterns of prime numbers or prime numbers plus 1 or cube numbers perhaps. Let's remind ourselves what those are. So 2 times 2 is 4, times 2 is 8. 3 times 3 is 9, times 3 is 27. 4 times 4 is 16, times 4 is 64. I doubled it and doubled it again. 5 times 5 is 25, times 5 is 125. So these are cube numbers. You might look out for those patterns as well. They can happen. And then if you want to take this a bit further, you can also look for Fibonacci numbers, which are very interesting. They're an interesting pattern to look out for. And you might like to go back and check your prime numbers as well as a pattern to look out for.